So here's something that confused me for a long time when I was starting out in engineering. Your CPU has 8 cores, maybe 16, and your GPU has 21,000 plus cores. And you just think like if more cores means more power, why don't we just put 21,000 cores in the CPU and makes everything faster? Well, the answer to this taught me more about how actually computer works than anything else. So, a core is basically a small processing unit that can read an instruction, do the math, and give you the result. Now, the key thing is that there are two types of problem in computing. The first problem is where the step 2 depend on the step 1. You can't start the next step until the previous one is finished. And this is called sequential processing. Example, opening an app on your phone is sequential. The system has to check which app you tap, then find the files for that app, then load them into the memory, then start the app. Each step needs the result of the step before it. For this kind of work, you need a core that is fast, powerful, and can make a complex decision. That's why CPU core is. A CPU has a fewer cores, but each core have a very high clock speed, has a large memory cache, and can handle a branching logic prediction and order of execution. That's why your CPU runs operating system and manages your file, handles your apps, and makes all the decision about what your computer actually does next. Now the second type of question is every piece of task is completely independent or not, and this is where the most important and interesting theory arrives. Example: your screen has a pixel. A 4K display has 8.3 million of them, and every single pixel needs the color of every single frame. Now the important thing is the color of pixel. One has nothing to do with the pixel of number two. They are independent, and they are independent in the calculations also. So you don't need one powerful core figuring out each pixel one by one. You can calculate all of them at the same time. And this is the concept of parallel processing. And that's why a GPU was designed for. A GPU core is simpler than a CPU core. It runs at a lower clock speed, it has less cache, and it can't handle a complex branching decision. Now, if you pack with 21,000 of them, 21,000 cores on one chip, and every core calculates one pixel color at the same time, you process 8.3 million pixel in about 60 milliseconds, and that's one frame at 60 fps. So here's the engineering behind this work. Inside a GPU, for example, NVIDIA RTX 5090, those have 21,000 cores, are organized into groups called stream multiprocessor or SMs, and each one has 170 SMs. Each SM contains 128 cores. Each SM also has its own logic, local memory, its own instruction schedulers, and its own register files. So when the CPU receives a task, it breaks the task into thousands of smaller threads, group those threads into blocks, and assign each block into an SM. And as every SM then runs the block thread in parallel at the same time across all 128 of its cores, and 170 SMs are doing the things simultaneously. That's how you go from millions of independent calculation to a finished frame in 16 milliseconds. And here the things connect much bigger. Example, training an AI model like ChatGPT is fundamentally a parallel processing problem. It's a matrix multiplication. You can take one matrix number, multiply it by another matrix, and bias, store the result, and repeat the procedure trillions of times also. And each multiplication in that matrix is independent of the others. They are not dependent on each other. So this is the exact same type of problem the CPU were built for. Independent, repetitive, simple math done trillions of times. So a CPU with 16 core would take months of time to train that same similar AI large model. But a GPU with 21,000 core will do the same procedure, matrix multiplication in parallel, and can finish in weeks or in days. For example, OpenAI trained ChatGPT using 10,000 NVIDIA GPU working together. So the same chip architecture that calculations or calculates a pixel color for your games in the same architecture that trained for AI you are probably using for every day. That the same parallel processing just applied to a different problem. So the reason your CPU has 8 cores and your GPU has 21,000 plus, not about which one is better, but they are designed for the different types of problem. A CPU solves a task where each step depends on the last few cores, but each one is faster and intelligent. Whereas the GPU solves the task where every piece is independent, thousands of cores, each one is simple but training running all at once. And the entire field of modern computer, from the graphics on your screen to the AI on your phone, is built on the understanding when to use and which one. So if you learn something new today, hit like. I will see you in the next video.